Question number 3. So, start the timer. A force acts on a cube of mass m that accelerates upwards along a vertical frictionless surface. Okay, this is a frictionless surface over here, and you are applying a force F in this direction. The magnitude of the force is F, and it acts theta to the vertical. Okay, so it is not acted like this, but it's acting in a slant angle over here. What is the question? The question is that what is the magnitude of the acceleration of the cube? Okay, so for this, what we need to do is we need to draw the free body diagram. And when the cube is going like this, accelerating like this, what are the forces acting over here? The first force that acts here is nothing but mg force that acts downwards. Okay, because it has a mass m, so definitely mg acts downwards. And since we have this f here, so therefore component of f acts in this direction. So this should be f cos theta should be like this. And component of this f acts in this direction. This should be f sin theta over. And there's also a normal force acting over here. Normal force acting over here. Or maybe, yeah, so you have all this over here. Now we need to account for the forces. Now where is the acceleration? It says that it accelerates upwards along a vertical frictionless surface. That means the acceleration is in this direction over here. So what we can do is we can now write, if A is in this direction, considering A to be positive, net force MA is equal to F cos theta minus mg. We should not be bothered about this. It's not required over here. We are only looking at this one here. Okay, sorry, f sin theta will not be like this. F sin theta will be like this. Like this will be your f sin. Okay, so therefore now we get this one here, and now what we have is I need to get the value of A. Okay, so therefore I will take A is equal to F cos theta minus mg divided by m. Let us see what is the answer here. Magnitude of the acceleration of the cube is F cos theta minus mg divided by